Hello everyone, I'm Thomas, and this is day 1 of 100 days of code in IoT challenge. Today's subject is the development environment setup and the first Hello World sketch. So for the environment, I'm going to start with Visual Studio Code installation. Then I try to connect my ESP board using the USB cable to my computer. And then I'm going to write some code. Okay, I think we just should start now. So let's install Visual Studio Code. In order to do that, the simplest way is basically type in VS Code in Google, then click on the first result, download it for my computer. And yeah, that's gonna take a few seconds. Okay, I'm going to press here. And yes, this is already extracted from the archive. So I'm going to move it to Applications. And now double click on Visual Studio Code. This window, yeah, I am sure I want to open it. Okay, so my Visual Studio Code is ready. And yeah, basically I cannot write any code for microcontroller yet because I don't have all the tools that I need. I can find all the tools here in the extensions. So extension icon is this one. Just pressed on it and I'm gonna look for C and C++ extension. That is Microsoft's one. So that's gonna give me all the IntelliSense that is really missing in Arduino IDE. Right, okay, that's installed. Another very useful extension is the Clang-Format. So that's basically auto format, auto indentation, and yeah, basically that's just it. Probably also improving the syntax a little bit. But yeah, I will show you this in action later on when we start writing some code. And the last one that I need to actually be able to send code, send the compile code and then send to the device is PlatformIO IDE. So I'm gonna install it. And straight after that, you can see now that there is a new icon here for PlatformIO. And when I click on this, I get a quick access menu and I want to press open. And that basically displays the home screen for PlatformIO. From this home screen, what we need to know right now is how to create a new project, because all of those other sections we're gonna use in the next days. For today, what we need to know is how to create a new project, which is basically possible. Which basically we can do by just pressing this button here. I'm gonna give it a name. I'm gonna call it Hello World 123. And the board that I'm going to choose is Node MCU. That's what you need to type in if you're doing it with me. And the one that we want to choose from here, you see there is Espress-if A266, and we want to choose the latest one. For the framework, we want to keep Arduino. So this allows us to, for the development to be very similar to how you develop code on Arduino, but with some extra features that PlatformIO gives us. Okay, so we see the welcome screen again, but we don't need welcome screen from Visual Studio Code. Yeah, so we have our new project created here. And just quickly, I'm going to go through the directory structure. So .pio, that's where the binaries and external libraries are. At the moment it's empty because basically my project is empty and there is no code that I have compiled. VSCode, this is just some configuration, I think that is used by the C++ plugin. That include directory, that's for the project header files. We're not gonna use it today. Yeah, same with library. This is for storing, like you can keep your private libraries here. So if your project grows bigger, you want to organize it, split out parts of the code. That folder, that library structure here, you can use. It is very useful if your case is basically that. Then I'm gonna skip for now the SRC folder. So yeah, test one is basically for the unit tests. Yeah, auto-generated git ignore. And we have a PlatformIO configuration file. And here you can put some additional options like for logging, like for the serial communication, and so on. Yeah, those options you see here, they're actually what we have chosen in the menu before when I was creating a new project. And finally to this SRC folder where our entry point is. And this is very similar to how it looks like on when you develop code for Arduino. You have a setup function and you have a loop function. And let me just explain how those functions work. So when you connect your device to the power source, the booting sequence is initiated. And what happens when this is initiated is this function setup to be called. And whatever is put inside this function is going to be executed, and that is going to be executed only once. Right after that, it's going to start execute whatever is inside the loop, and it's going to do it repeatedly. So it's just going to continue on and on, just calling loop, 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 on and on. And that's going to actually continue until you disconnect your device from the power source. And basically when you reconnect it back, it's just going to start from the setup again, and then again loop, 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 loop. So you have to bear this in mind when you develop your code, that this actually is going to be run indefinitely as long as the device is connected to the power source. Okay, so now I'm going to write a first program, a first sketch that I'm going to deploy to my device. However, before I do this, I actually need to connect this device to my computer. So what is needed to connect it to the computer? In my case, I need USB-C to the standard USB adapter. So I'm just connecting it to my computer. Just did that. The second thing is the USB cable. It's just the micro USB on this side and the standard USB on this side, which I'm just connecting to the USB-C adapter. And yeah, the micro USB part, you just need to connect it to this port. Let me just show you this port in here. So yeah, that's gonna be basically like, let me just, yeah, it's just gonna be like that. Okay, so yeah, it is connected. And now, in order to check if the connection is working well, the only thing I need to do is to press on this arrow here. because PlatformIO is really smart, and it's actually detecting automatically if your device is connected. And as you can see here, it's actually writing to the device. So that means the connection was successful. One thing that I need to mention on this, and this is very important, you may get an error, a connection error. And the main reason usually is the cable, because some of the cables just don't work with ESP8266. So yeah, you still need to use, you're still using the standard USB to micro USB cable, but some of those cables don't work with this device and some do. I had to test like 4 different cables, and only one from all of those worked for me. So that would be the first reason why it's not working. That's like 90%. The reason this is not working and you cannot deploy your sketch is because you need to use the different cable. So I really encourage you, if you want to do it with me, or if you want to experiment like on your own, I really encourage to try different cables. Just buy some. Yeah. So yeah, just one thing I really wanted to note. Okay, let's write some code. Yeah, so I'm gonna start from removing those comments since we don't need them anymore. And right, so in order to send some text from the device to my computer, we need to use a serial communication. And that serial communication needs a setup step, which is basically calling the static method that is called serial begin. It takes one argument, which is a baud rate. And what the baud rate is basically the amount of data that's being sent per second. It's the amount of bits, the number of bits that are being sent per second from the device to the computer over the cable. They all send one by one sequentially. This is what the whole serial communication is about: sending a bits of data one by one sequentially at a certain speed, and that speed is a baud rate. What I'm gonna use is a very common baud rate for ESP, which is quite high. It's 115,000 bits per second. And this line is going to be run at the setup. We just need to call it once just to tell the serial communication that this is going to be the speed of communication. And now on the loop part, there's going to be another static method to use. It's called println. Name is quite common actually. Just gonna say whole word here, and this is it. Now I'm gonna press this arrow button here again to compile and deploy my sketch again. It's gonna take a while. Okay, it's done. It is done, but we don't see any hello words here, and the reason is it is because we have to open the serial monitor to see that information, to see what has been received. And the serial monitor can be opened just by pressing here. So I'm gonna do that, and I'm getting something. But the format of this is not actually correct. I see that we're just getting like repeatedly some sort of information, but this is definitely not hello world, right? The reason this is not hello world is basically because that device has a different default baud rate set. And this is very common issue with the serial communication on ESP boards. And the fix for that with PlatformIO is very, very simple. What we have to do is to go to platform.ini and just type in monitor speed equals the same speed that has been set on the serial in our main file. I'm just gonna send it again. As you can see, it's compiling everything again. The reason is whenever you change something here in the configuration file, it has to compile everything from scratch again. Okay, now we can see hello world. It's a lot of hello worlds, right? It's quite fast, lots of them. I'm just gonna slow it down, and to do that, there is another function that I'm going to use. That function takes a number of milliseconds. So I would like hello world to be displayed every second. And that's what I'm gonna do right now by just calling delay with 1000. Okay, yeah, it works. Now we see hello world appearing every second. Right, let's improve our program a little bit, and maybe let's make it more cool. It's not gonna be super cool, but what we can do now is to use a built-in diode in here. Just this one. It is here. It's not really, I cannot really show you, but it is here. And we can use the diode and set it up. Just take control over this diode. In order to do that, I'm just gonna use pin mode function, and to get the diode, basically every single pin here, as well as the built-in diode, has its equivalent in a number, because like everything is actually binary on the board, so everything sits behind a certain number. To access this number, we can use a constant. So what we're doing now is we're changing the mode of this pin, which is the built-in. Actually, I should use let built-in, because that one is deprecated. Let built-in, that is actually 2. And we're setting it to output. That means we basically taking control over the amount of voltage. It's not really an amount, it's like whether the voltage flows. We actually take control. Actually, we take control over the amount of voltage, because we can set it to low or high. We cannot really tell. We cannot really set the exact number, but we can basically tell whether the voltage is high or it's low. Right. So now I'm going to modify hello world message to low voltage. I'm going to add another, and I'm going to say high voltage. And in between, I'm just going to use another function. It's called digital write. And for this one, we're still gonna be sending information to a let built-in, and the value is going to be low. We'll have a delay here. So we have low voltage. We're gonna change actually we're gonna do this. So change the voltage to low on the LED. Then we wait for 1 second. we print out high voltage, then we change voltage to high, and then we wait a second again. Let me just deploy this code. And we're gonna be able to see if this code works and the diode is blinking here. Let's give it a few seconds. Okay, so we see high voltage and low voltage, and the diode is blinking. I'm pretty sure you can see that here. Yeah, one thing that is worth mentioning is the fact that when the low voltage is printed out, the diode actually is switching on, and the high voltage is actually switching it off. And this is actually how it works with the built-in LED. So yeah, something to remember. Okay, that's it for today. Thank you very much for watching. I've managed to accomplish the challenge, and really excited for tomorrow, because tomorrow I'm gonna be building something with the breadboard. So yeah, see you until then. Bye.